What's up, everyone? In this video, we're going to be going over finding volume of cones and of pyramids. So here's a refresher of just what volume is. So remember that volume is equal to the area of the base, and again, your base can have different shapes, and we multiply the area of that base by the height of our figure. So here are just some three different examples of prisms with different bases. So here we have a rectangular prism, so we do length times width as our base. Here we have a triangular prism, so 1/2 BH is going to be our area of our base. And then for a cone, we have pi r squared times our height. So remember that a pyramid can also, similar to prisms, it has a variety of shapes as their base. But for a prism, every other single face was a rectangle. And since a pyramid comes to a point, we have to have all of our other faces as triangles instead. Now, the amount of triangles is going to depend on the number of sides that are in our base. So for example, if we have a square pyramid, our base is a square with 4 sides, so we know that there are 4 triangles in it. For a pentagonal pyramid, right, we know that a pentagon has 5 sides, which means that there are 5 triangles in there. So knowing the difference between a prism and a pyramid is very important. Now, these are the formulas for volume of pyramids and cones. You are actually given both of these on your reference sheet. Now, the volume of your regular prism or cylinder is capital B times H, but when we're doing it for a pyramid or a cone, we just take that same thing. We do capital B times H, but we divide it by 3. So it's 1/3 BH. Or, instead of writing 1/3 BH, you can write it as B times H over 3. Now, if we visit our reference sheet, you will see that for cone, you'll see that for cones and for pyramids, it is given to us exactly like that. Now for cone, we have 1/3 of pi r squared times the height. And for pyramid, it just gives us 1/3 of capital B times H. But that, again, that capital B depends on the shape of your base. Now let's do an example of finding the volume of a pyramid. So a tent is in the shape of a right pyramid with a square floor. The square floor has side lengths of 8 feet, and it says that the height is 6 feet. So I like to make a list. So we have a side is 8 feet, we have that our height is 6 feet, and we're also going to draw a picture. So we draw a square, then we draw a bunch of triangles meeting at that one point. So if our base is a square and it gives us one side length of the base, we can fill in that side length everywhere else because all 4 sides of a square are the same. And it gives us that the height is 6 feet. So that height is going to go kind of like right here. That's 6 feet. Now, the formula for volume of a pyramid, again, we have area of the base times the height, and we're going to divide that by 3. Or we're going to do 1/3 of capital B times H. Now, our base is a square. To find the area of our square, we do length times width. So 8 times 8 is going to give us 64. Our height is 6. So we do V equals capital B, our area of our base was 64, times our height, which is 6, and we got to divide that by 3. And when we do that, we get 128, and we get feet cubed for our volume. Now, in another example, we might have to use the volume to find some other dimensions. So we have the base of a pyramid is a rectangle with a width of 4.6 centimeters, a length of 9 centimeters, and it wants us to find the height. So we have W is 4.6, we have length is 9, and then we're looking for the height. And it also is giving us, it says the volume of the pyramid is 82.8 centimeters cubed. So we got to write the full formula out. So the volume formula is going to be 1/3, and since we have a rectangular prism, you guys remember from the previous lesson, it's going to be 1/3 of length times width times height. Now when we substitute our values in, our volume is equal to 82.8, our length is equal to 9, our width is equal to 4.6, and our height is what we're looking for. That's what we're going to put in as x. Now, there are a couple of different things that you can do here. What I like to do is I'll get rid of this 1/3 right away to make it a little bit easier to see. So here we'll get 248.4 equals 9 times 4.6 times x. So 9 times 4.6 is going to give you 41.4 times x. Now to get x by itself, you just divide by 41.4 on both sides. And when we do that, we're going to get that 6 is equal to our height. Okay. So our next example is finding the volume of a cone, and this is a good one because they give you the whole formula. So on your reference sheet, you're given 1/3 pi r squared times height. So it says a cone has a diameter of 16 inches and a slant height of 17 inches. What is the volume of the cone in cubic inches? So one thing I need us to be mindful of is that we need the radius. To find the volume, we need the radius and we need the height. So the radius, we're able to figure out the whole diameter is 16. We're able to figure out that our radius is 8 just by using that relationship between diameter and radius. But they give us our slant height. Now, slant height and regular height are very different. Our regular height is measured straight up and perpendicular to the base, right? Our slant height is not going to suffice. Like if we plugged in 17 in for h here, we're going to get the wrong answer. So what we need to make sure that we do is let's use our prior knowledge. We have a right triangle here, and if we redraw that right triangle, we have 8, we have 17, and we're looking for this side right here. So we got to use Pythagorean theorem. We have a squared plus b squared equals c squared. 8 squared plus x squared equals 17 squared. Remember that your hypotenuse has to go in for c. So we get 64 plus x squared equals 289. And if we subtract 64 on both sides, we get x squared equals 225. And then when we take the square root of that, we get that x is equal to 15. Now going back to our diagram, we should always fill this in. 15 now is our actual height. So now when we go ahead and substitute into the volume formula, we have v equals 1/3 of pi. Our radius is 8. We're squaring that, and then we're multiplying by the height of our cylinder, by the height of our cone, which is 15. So you can literally go ahead and plug this all into your calculator. And it doesn't tell us what to round to, so we're just going to do both. So if we plugged it all into our calculator, we would get 1507.964. But in terms of pi, it would be 320 pi. Okay, so if it doesn't specify, you could do both, or usually it will specify. Oh, it actually does tell us. It tells us in cubic inches, so you're going to have to use this answer right here. So 1507.964 inches cubed. All right, now last but not least, this is going to be, this is our first word problem for cones. So here it says a cone has a volume of 108 pi and a base diameter of 12, and it wants the height. So when they're giving us the volume, that's a dead giveaway. You should just write out the whole formula first. 1/3 pi r squared h, or you can write v equals pi r squared times h over 3. And let's just substitute. So I'm going to do it in this on this side. So we have 108 pi equals pi. Now our diameter is 12, and if our diameter is 12, that means that our radius is going to be 6, and we are looking for our height. So I'm going to leave that as h. Now what we do is we got to multiply by 3 on both sides. And when we do that, we're going to get 324 pi equals pi times 36h. Now we see pi on both sides of the equation. When that happens, we know that they're going to cancel out. So if we rewrite it, we get 324 equals 36h. And now we got to divide by 36 on both sides to get our height by itself. And if we do that, we get that 9 is equal to our height. All right, so make sure you guys are using your reference sheet to help you. And make sure you choose which method you want to write it out. So if you're comfortable with doing 1/3 and putting the rest of it in front versus dividing by 3, you can pick and choose what you're more comfortable with, and then you can just utilize that moving forward.